All right, continuing on here. The next part of it, well, and we'll leave it as just that one for that section. The next section used the double angle identities, which again you should have on your sheet. And so the first one we'll look at is number 31 on that section. It's asking you for the cosine of 2 theta, but it has given you up in the instructions that the cosine of theta is 3 over 5. So then you go down your identities. Your identity for this one, you can use cosine squared theta minus sine squared theta. So obviously I have to figure out what the sine of theta is here. So again, I'm going to draw out my triangle. I'm standing right here. Cosine is adjacent over hypotenuse, so that's 25 minus 9. So this is going to be the square root of 16 here, or 4. So I'm talking 4 over 5 as my sine of theta. Then if I plug them in, I'm going to square that, so I have 9 over 25. I'm going to square that, so I have 16 over 25. So what I get here is negative 7 over 25, which is my cosine of 2 theta. So it really, truthfully, is just a matter of plugging in. I'm going to skip on down to number 30. Well, I would have to find the sine of 2 theta as well. So let me go back. If you did, okay, that gives me the sine 31. Actually, this is 30, because I need both of these to be able to do 33. The sine of 2 theta, and I'm going to use this identity, but I'm still using that stuff up there. So it's 2 times 4 over 5 times 3 over 5 is going to give me 24 over 25. So I have this answer and that answer. So then on 33, when it asks me the sine of 4 theta, that is the same thing as 2 times the sine of 2 theta times the cosine of 2 theta. Okay, so it's using the answer that you got for both of those. So 2 times the sine is 2 times 24 over 25. The cosine of 2 theta is negative 7 over 25. You just multiply that all out, you get negative 336 over 625. So basically what you've done is exactly what you did here, except for here and here you substitute your 2 theta, because that's what your 4 theta is equal to. All right, so that's that section. Then you moved on to section 7.5. You solved equations in this section. So you applied all your identities and then solved equations. So looking at number 35, they give you the sine squared x plus the cosine squared, or plus 2 times x, minus the cosine x equals 0. And the instructions say solve each equation for when x is greater or equal to 0 and less than or equal to 360. So what I'm going to do, I'm looking at this is a trinomial. So what I want to do is I want to factor it. I think, yeah. So when I do that, well, actually I'm not going to factor it. I'm going to separate this, okay? The sine squared x plus, my identity there is cosine squared x minus sine squared x. Then I add my cosine, my negative cosine of x there. So once I get that, then I can, let's see. I'm looking here, that and that cancel out. So that and that are done, so I don't have to worry about that. So cosine squared of x minus cosine of x equals 0. Looks like I can factor out there. So I have a cosine of x minus 1. If I set these both equal to 0, I want to know where the cosine is equal to 0. And then when I solve this one, I want to know where the cosine is equal to 1. So the cosine is equal to 0, and you can do it in degrees or you can do it in radians. At 90 degrees, at 270 degrees. And your cosine is equal to 1 at 0, and you could say 360, but we don't need to, that's the exact same spot as 0. So those would be your 3 answers. I guess you need to put degrees there. Okay, so that's number 35. Number 37 changes things up and says solve for all real x's. So then you're not limited to the 360 degrees. You are wanting to make an equation that accounts for all answers. So here's what I have. I have the sine of x times the tangent of x minus the square root of 2 over 2 times the tangent of x equals 0. I think what I'll do is I'll factor out the tangent of x, leaving me with a sine of x minus the square root of 2 over 2 equals 0. So here, I'm going to set the tangent of x equal to 0. Okay, the tangent of x is equal to 0 at 0 plus, it would also be 180 degrees, which would be pi times k. So at 0, and then every time you go 180 degrees or pi radians. So that's going to be my equation for that one. Then I'm going to come over here, and I'm going to solve this, and when I do, I'm talking about the sine of x is equal to the square root of 2 over 2. Now that is going to be at 45 degrees, or if you will, pi over 2. It's also going to be at 135 degrees, which is 3 pi over 4. So you could do this as 45 and 135, or you can do them in radians. This is going to equal, every time you go around the circle, so 2 pi k, whether it's one time around the circle, 2 times around the circle, or so forth. 2 pi k every time you go around the circle. So that's written in terms of radians. You could write it in terms of degrees as well, though. So that is going to be your 37. I think we'll let that one stand right there, that section, and we'll go on to the next section. The next section, you're going back and forth between a normal form of a line and a standard form of a line. That involves 2 equations, and it involves converting back and forth. So you have the normal form, which has to do with your trig, and you have your standard form, which you know what the standard form is. You're talking, I can spell it right, you're talking ax plus by, and I think they've got minus c there. Let me go back and look in your book. I think that's the form they use. They say plus c, okay, equals 0. Then your standard, or your normal form, which is based on trig, is x times the cosine of phi plus y times the sine of phi minus p equals 0. This is the angle. Phi is the angle that's formed to the line, and p is the distance from the line. And we worked back and forth as far as how you convert between these two. If they give you one, you should be able to convert to the other one. So if you look at 41, they give you two things. They give you pi is equal to 5, which is your distance to the line. They give you, the p is 5, phi is 90. So literally what you're doing is you're substituting in right here. So I have x times the cosine of 90. This is going from basically from your normal form to a standard form, plus y times, and I'm substituting in here, the sine of 90 minus 5 equals 0. Well, at 90 degrees, which is pi over 2, my cosine is 0. My sine is 1. So, in standard form, I have y minus 5 equals 0. You could put 0x plus y minus 5 if you want, but this right here is the standard form of the normal form that has p of 5 and phi of 90. If you look at 43, the only thing that changes are these two things. You have 4 on the square root of 2, and you have 225 degrees. So, my conversion is simply x times the cosine at 225 plus y times the sine at 225 minus 4 on the square root of 2 equals 0. Well, the cosine at 225 is negative square root of 2 over 2, and the y is also negative square root of 2 over 2 minus 4 on the square root of 2 equals 0. Well, the one thing that I am not supposed to have, I am not supposed to have a negative x, and I'm not supposed to have a fraction. On these, I can have a square root, but I am going to multiply everything by a negative, well, actually, I'm going to get rid of the square roots as well. So I'm going to multiply by a negative 2 first, which is going to give me the square root of 2x plus the square root of 2y. And that's going to give me positive 8 on the square root of 2. Then I'm going to divide everything by the square root of 2, and I'm going to be left with this. And that is standard form of all of this being from normal form. Remember how we weren't supposed to have decimals, we weren't supposed to have square roots, and we weren't supposed to have a negative in front. All right, that is number 43. If you move on to the next part, it says write each equation in normal form, then find the angle length and find the length of a normal and the angle it makes. So this time I'm going from here back to here. So they give me the equation in number 45, and this is the equation. 6x is equal to 4y minus 5. But I've got to move everything into one side of the equation so it matches here. So I have 6x minus 4y plus 5 equals 0. Then the method to change from this to this is I'm going to divide it by, and it's going to be the opposite sign of your c. So in here it's going to be negative. The square root of this, a squared, plus b squared. So right here, I'm going to have the square root of 36 plus 16, which is the square root of 52. So I have 6 over negative square root of 52, x minus, actually it becomes a plus because I have a negative over a negative, 4y over the square root of 52 plus 5 over negative square root of 52 equals 0. Well, I can't leave it like that, so I would have to convert it. And when I convert it and reduce it, this is 3 on the square root of 52 over 13, and that's just reduced down. Oh, actually, this is broken down too. Because 52 is, let's see, 13 times 4, so I take the square root of that. So when I break it all down, I get to there. Maybe I better show you that. Okay, so I've got 6 times the square root of 52 over 52. But this is equal to 4 times 13. So the square root of 4 times the square root of 13. So square root of 4 is 2. So I've got 12 over 52, which is going to reduce down. So let me just go ahead and show you, and I'm going to do that there, and I'm going to do that there. So let me show you it reduced down. I have negative 3 on the square root of 13 over 13 plus 2, and there's an x there, 2 on the square root of 13 over 13y, and minus 5 on the square root of 13 over 26 equals 0. Now that right there, you've got a start in your right direction. You can find your p from that. So that's your p, which is, they're asking you for that. So p is equal to, and it's neither positive nor negative because it's a distance. So p is equal to 5 on the square root of 13 over 26. But now I've got to find my phi. And to find my phi, I'm going to use the tangent of phi is equal to sine over cosine. So when I do that, and I'll come down here, I'm going to go this over this. My 13s are, when I invert and multiply, they're going to cancel out. So I'm going to have 2 on the square root of 13 over negative 3 on the square root of 13. Those go away. So I'm going to do inverse tangent of that. Now, I know it's going to be, remember this is my sine, this is my cosine. So I am looking for where my sine is positive and my cosine is negative. So this is going to be in the second quadrant. I know that. So when I do inverse cosine, I'm going to get a negative 33. Well, guys, you know that's down here somewhere. I want it over here. So I'm going to add 180 to it, and I'm going to get 146.3. Okay? You're talking in degrees, so your calculator needs to be in degrees to do that, but it should be. All right, so that is number 45. 47, let's do one more like that, because those are a little complicated. My standard is x minus 7y plus 5 equals 0. So I'm going to divide it by a negative 1 squared plus 7 squared. So I have a square root of 59. So I'm going to have x over negative 5 on the square root of 2, because I broke down 50 into 25 times 2, plus 7y over 5 on the square root of 2, minus 5 over 5 on the square root of 2. All right, I've got to rationalize, so I'm going to have square root of 2 over negative 10, x plus 7 on the square root of 2 over 10y, minus 5 on the square root of 2 over 10. So this right here is the p